In this video, we are going to discuss curve representations. So what are the different categories? We shall discuss that one and also into the details. There are mainly three ways with the help of which you can represent one curve mathematically. The first one is the implicit curve representation. Next one is the parametric curve representation. And the last one is our generative or procedural curve representation. So there are three different curve representations. So one is the implicit, parametric, generative or procedural curve representation. So let us go one by one. At first we are starting with this implicit curve representation. Implicit curve representations define the set of points on a curve by giving a procedure that can test to see if a point is on the curve or not. So we shall select a point and we shall check whether this point is falling on the curve or not. So usually an implicit curve representation defined by an implicit function of the form that is f of x comma y is equal to 0. That is a function of x comma y is equal to 0. So that the curve is the set of points for which this equation will be true. Note that the implicit function f is a scalar function and it returns a single real number. So that is our implicit curve representation using some implicit function. Next we are going for this parametric curve representation. So the parametric curve representations provide a mapping from a free parameter to the set of points on the curve. And that is, this free parameter provides an index to the points on the curve. The parametric form of a curve is a function that assigns position to values of the free parameter. So now question is coming in the mind, what is the free parameter? If you think of a curve as something you can draw with a pen on a piece of paper, then the free parameter will be our time. So along with the progress of the time, we will be having a successive points which will be drawn on the piece of paper using a pen. So ranging over the interval from the time that we began drawing the curve to the time that we finish. The parametric function of this curve tells us whether the pen is at any instant of time, where the pen is at any instant of time can be expressed with this particular form, that is xy is equal to function of time, function of t. Note that the parametric function is a vector valued function. This example is a 2D curve, so the output of the function is a 2 vector. In 3D it would be R3 vector. Now the question is coming, why parametric curve representation? Because it is simple and flexible and the function of each coordinates can be defined independently. So just consider this one, that is a x of t comma y of t, that is 1D curve in the 2D space, x of t comma y of t comma z of t, that is 1D curve in 3D space, and x of s comma t, y of s comma t and z of s comma t is the 2D surface in the 3D space. So polynomials are suitable for creating smooth surfaces with less computation. So here we are having one respective equation for that. Now we are having the last curve representation technique, that is our generative or procedural curve representation. So generative or procedural curve representations provide procedures that can generate the points on the curve that do not fall into the first two categories. Examples of generative curve descriptions include subdivision schemes and fractals. So that we will be discussing in our other videos. So in this way, we have shown that what are the different types of curve representations are possible and what are their respective merits and demerits. Thanks for watching this video.